last video I showed you how to add binary numbers, and in this video I want to show you how to subtract binary numbers. So it turns out that subtracting uses the same algorithm as addition, and the way you can do that is, let's say that we have x minus y. This can be rewritten as x plus negative y. So then this brings up, well, okay, then we need a way to represent negative numbers in binary, because we're adding a negative number to a positive number. And you might wonder why there's not just a subtraction algorithm for binary numbers. The reason why is because the subtraction algorithm is much more involved than the addition algorithm. The addition algorithm is pretty simple, so it makes sense to just go ahead and use it for subtraction as well. And so what I'm really talking about in this video is, first of all, how to write negative numbers in binary, and then a review of how to add numbers in binary. So numbers can be represented in binary using three different methods. So there's three methods to represent negative numbers. The first method is what's called the signed magnitude representation. There's a method called ones complement and twos complement. So in this video, I'm only going to cover the twos complement. This is by far the most common method used to represent negative numbers in binary. So for the twos complement, it just involves three steps. First of all, you write your number in binary. So the positive number in binary, so let's say we have like negative 90, we would write 90, so I don't want to put 90 there, but we would write 90 in binary. So the positive version of the number. The second step is to flip the bits. And what this means is taking let's say you have 0, 1, 0, 1, 0, 0, 1. To flip the bits for this number, you just take the opposite of each of these bits. So it would go, so the 0 would become a 1, the 1 would become a 0, so this would become 1, 0, 1, 1, 0. The third step is to add 1. So let's do an example. Let's calculate 7 minus 2. So first of all, we want to rewrite this, so we're using our addition algorithm. So this would be 7 plus a negative 2. And so first of all, we can write 7 in binary. This is just 0, 1, 1, 1. And if you want to review about how I got the 0, 1, 1, 1 from 7, go back to the video on how to write binary numbers. And so then the negative 2, first of all, we write the number for 2 in binary. So this is 0, 0, 1, 0. And this is assuming we have 4 bits. So each number is 4 bits. So this is equal to 2 in binary. Now what we want to do is flip the bits, because we want to convert this to negative 2. So to flip these bits, this would be 1, 1, 0, 1. And so this is, I'm just going to put flip bits. And then we want to add 1 to this. So I'm just going to put 1 there. So add 1. Now we just do our addition rules. So if we have a 1 and a 1, then we carry a 1, drop down a 0. If we have a 1 and a 0, we drop down 1, and then we have 1, 1. So this 1, 1, 1, 0 is equal to negative 2 in binary. So now we just add these up. So we have our number for 7. So we have, and we're doing 7 plus negative 2. So we write down 7. So 0, 1, 1, 1. And then we write down our binary number for negative 2. So this is 1, 1, 1, 0. We add these together. We have a 1 and a 0, so we drop down a 1. We have a 1 and a 1, so now we have a 1 and a 1, so we carry a 1, drop down a 0. Now we have 3 1s, so we carry a 1, drop down a 1. And we have 1 1, so we carry a 1, drop down a 0. And then we drop down a 1. So since we were assuming that we only had 4 bits available, this is the only portion that would be read. This 1 here would be dropped off as what's called an overflow. And so if we add this up, so we have, well, and first of all, 7 minus 2 is equal to 5. So we're expecting to get 5. So if we add this up, we have 0, 1, 2, 3. So we can verify this by just adding these up. So we have, well, so this is 1, 2, 4, 8. So we have a 4 and a 1. So 4 plus 1 is equal to 5. So that means that we got the correct answer with this. And I can also write this out in a little more detail. So this would be the 0 spot, 1, 2, 3. So we have 0 times 2 cubed plus, and then we have a 1 here, so 1 times 2 squared plus, and then we have a 0 here, so 0 times 2 to the 1 plus, and then we have a 1 here, so 1 times 2 to the 0. So then this is equal to 0 plus 4 plus 0 plus 1, so that's equal to 5. This is how you subtract binary numbers. It's basically the same thing as adding binary numbers. You just need to convert your binary number into, you need to convert the one that you're subtracting into a negative number. So now I want to show you one more example of how to convert a binary number into a negative number using negative 94. So just erase this real quick. Okay, so let's write negative 94 in binary. So the first thing we want to do is determine what 94 is in binary. So find binary for 94. And if you remember from a previous video, I showed you and there's a few different ways to do this, so just whichever way works best for you. I think this way is pretty straightforward. So I like to write down a little chart of the numbers. So 2 to the 0 is equal to 1, 2 to the 1 is equal to 2, 2 squared is equal to 4, 2 third is equal to 8, 2 fourth is equal to 16, 2 to the 5th is equal to 32, 2 to the 6th is equal to 64, and 2 to the 7th is equal to 128. So one thing to notice with this, and this is with the binary system, each time you move up, it doubles your number. So if we want to write 94 as binary, first of all, 128 is larger than 94, so we want to start with 64. So we have 64 plus, and then we want to figure out what we need to add to 64 to get 94. So 64 plus 30 is equal to 94. And then 32 is greater than 30, so we go to 16. So 16, and then we want to figure out what we need to add to 16 to get 30. So 16 plus 14 is equal to 30. And then going down to 14, 16 is greater than 14, so we go to 8 plus 6 is equal to 14. And then 6 can be split into 4 plus 2. So now we can write down the spaces for our binary number. And I'm going to assume this number is 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8. And I can just fill in what the different spaces are real quick. So this is 1, 2, 4, 8, 16, 32, 64, and 128. So coming back over to this number, first of all, we don't have a 128, so that's 0. We have a 64, so this is 1. We don't have a 32, so this is 0. We have a 16, so this is 1. We have an 8, so this is 1. We have a 4, and we have a 2, and we don't have a 1, so that's 0. And so you can go through and verify this if you add up 64 plus 16 plus 8 plus 4 plus 2, it should equal 94. So, but we're not looking for 94, we're looking for negative 94. So the next thing you want to do is flip the bits. And so what you want to do for that is just anywhere that you have a 0, you put a 1, and anywhere that you have a 1, you put a 0. So this would be, well, I'll write down the original number first. So 0, 1, 0, 1, 1, 1, 1, 0. And this becomes 1, 0, 1, 0, 0, 0, 0, 1. And then to get the 2's complement, we want to add 1 to this. So add 1. And then we just do the regular addition rules. So we have a 1 and a 1, so we carry a 1, drop down a 0. We have a 1 here, so we drop down a 1. And then we have some zeros. 1, 0, 1. So this is equal to negative 94 using 2's complement. And just make sure you're clear about what kind of negative number representation is being used, because there's more than one, but 2's complement is by far the most common. In the next video, I want to show you how numbers are represented with floating point notation.